What is the magnitude of the net force on charge A due to the charges B and C? Well, we're going to cheat a little bit here. We've already worked the problem where we found the force on this charge due to these two, but look what happens when I just rotate this around. It's the same problem, okay? We have an equilateral triangle and we're trying to find the force on this charge up here. So let's get rid of that. And what we're going to do is bring back the solution we've already done here. So we'll look over here at the diagram. We resolve the forces on this charge here from both of these. We've got this force is coming from this charge, this force is coming from this charge, and then we know that the hypotenuse here, these forces will be equal because this distance is the same, the charges are the same. So we'll move this guy up here out of the way, bring here. So along the y-axis, what we have are the two components add. And each individual component is going to be the hypotenuse. This force here will be kqq over r squared, or kq squared over r squared. We then find the y components, and that's the value of this force times the sine of this angle. So here we have total force in the y direction is FAC times the sine of theta plus FBC times the sine of theta equals 2F sine theta. Here is our force, our total force due to each charge. We move that down here. There's two of them, so there's our 2. The sine of 60 is because this is an equilateral triangle, and we get the total force in the y direction is radical 3k q squared over r squared. There is no force in the x direction because this component cancels this one. So the answer is going to be D. And you can actually go back to the presentation and also see this worked out there. So our answer is D.